Alright, so if we're interested in the global maximum and minimum, what I would check is my stationary points, because they may be the global maximum minimums, and my endpoints, because you can kind of sketch an idea of the curve once you've found those points. So a y dash, I'm going to get 3x squared minus 12x plus 9. Where does that equal 0? So I've got x squared minus 4x. I feel like we've done this one before, maybe. So I'm going to get a 3 and a 1, and I want those to be negative. There we go. So at x equals 3 and 1, I'm going to get, so I've got like this, 3, and let's say that's 1, 2, and that's 3. If I put 1 in, that should be easy. So 1 minus 6 is plus 9 minus 4. I think that's right. So I've got 10 take away 10 is 0. Nice. Alright, so this is going to be a stationary point. 1, 0 is a stationary point. And actually, if I put that into, if I put either side in, for example, if I put 0 in, actually, we could just find the point of the y-intercept, which is negative 4. So I know it's going to come down here and cross through at minus 4 anyway. So I'm guessing that, but I could always check, for example, 2. And when I put 2 into y dash, let's put it into there, I've got 3 times minus 1 times 1. So I'm going to get a negative. So I know it's a negative, it's decreasing. So I know that that point, 1, 0, is a local maximum stationary point there. What about when I have 3? So when I sub 3 in, I've got 3 cubed into here, minus 2 times, again, 3 cubed, plus 3 cubed, minus 4. Alright, so I've got 2 3 cubes, take away 2 3 cubes, minus 4. So it's going to be minus 4. So it's going to be down here. And if I go either side, again, this was going down to the stationary point. So this, if I look at 4 and put that in, I'm going to get 3 times 1 times 3, which is positive. So it's going something like this, right? So I can see where my local maximum and minimum would be, but I'm interested in a global maximum minimum. So I really should just check my endpoints. So you can see my endpoints, I'm only going between x equals a half, I'll do it in a different colour, a half, so when I put a half in, so I'm only going up to here at that point, so I can kind of get rid of that. So what is my height when I sub a half in here? So if you sub a half into there, we get 1 on 8 minus 6 on, oops, yep, 6 on 4, that doesn't look like a 6, plus 9 on 2 minus, let's say 8 on 2. So we've got 1 on 2 for that bit. 1 on 2 is 2 4s. So minus 6 plus 2 is minus 4 on 4, so minus 1, which is 1 on 8 minus 8 on 8, if you followed me there. So that's minus 7 on 8. So I know that this is minus 7 on 8. That's how low that goes. So remember, I know this one comes down to minus 4. So this is lower. So that's great, right? So that minus, that endpoint is not going to feature in my answer. And then if I use my other endpoint, which is 5, I might use my calculator. So if I put 5 in there, I get 5 cubed minus 6 lots of 5 squareds plus 9 lots of 5s minus 4. So actually I'll put that in my calculator, and I think we get, yep. Alright, so we get 16, I think. So this is going to be 5, 16. Now you can see that's a lot higher than our local maximum stationary point. So when I'm looking for my global maximum, that's going to be 16, right? My global maximum is going to occur there, so it's going to be 16. My global minimum is going to be minus 4. Okay? So it's also my local minimum, but it's my global minimum there. So always check your endpoints as well as your stationary point.